Now we're going to talk about a property of square matrices, and that would be the determinant. So with a square matrix, they have a scalar property to them known as the determinant, which I'll show you how to find for a 2 by 2 and a 2 by 3 matrix. So let's say we have matrix A. We're going to say A is equal to just the variable entries A, B, C, and D. So these are all real number values, but I'm using variables, so we have a general formula for our determinant here. And when we have a 2 by 2 matrix, we can say the determinant of A, and we can have two different notations for this. Determinant of A, which is equal to, we place two vertical bars around A. So when you see two vertical bars around a matrix around a matrix, that also means the determinant, which I'll show one more example, equals like this, A, B, C, and D. So all three of these things mean the same thing, determinant of A, and the determinant of this matrix, which is equal to matrix A. And what we're actually doing here is we're going to take the terms in the upper left and lower right corner and multiply them together. So we'll have A times D, and then we're subtracting away the other two terms multiplied together, minus B times C. So that'll get us our determinant for this 2 by 2 matrix. If we want to, or let's take a look at an actual example with some real numbers so we can get some practice here. So we'll have matrix A is equal to 2, 3, 3, 4. And if we want to find the determinant of A, we will say that's equal to 2 times 4 minus 3 times 3, which will get us 8 minus 9, which is equal to -1. So the determinant of this matrix is equal to -1. Now let's go ahead and see what this looks like with a 3 by 3 matrix. They're fairly more complex for 3 by 3s, but they're still not too hard if we take our time and organize what we're doing. So in this time around, we'll have let matrix A equal to, and I'm again going to make a variable matrix, A, B, C, D, E, F, G, H, I. All right, now when we've got our 3 by 3, the easiest way to do this is to take our first two columns and we're going to recopy them over. So A, D, G, B, E, H. And what we're going to do is take or follow along diagonally downwards, starting with our first position here. And we're going to do that 2 more times, moving over. So we have these 3 diagonals. Likewise, we're going to need to we can start with G in the bottom left, and we're going to make 3 more diagonals going the other way here. And when we actually want to calculate our determinant, we can say that the determinant of A is equal to, we're going to take 6 products here. We're going to multiply along these diagonals, and what we're doing in orange, we're going to add together. So we'll have A, E, I. We're going to add that to B, F, G, and then add C, D, H. And we get these 3 products in here. And then we're going to subtract away the sum of the other 3 products. So we're going to subtract CEG plus AFH plus BDI. Again, let's get a little bit of practice to see what that looks like with some real number entries here. So notice, I recopied down our first two columns just on the outside of our matrix. And now I'm going to make my diagonals. And then let's find our products here. So we've got the determinant of A is equal to, and I'm just going to write my products out. We've got -9 plus 64 plus 2. We're going to subtract -8 minus 12 minus 12. Or again, my -9, 3 times -3 times 1 gets me -9. 4 times 4 times 4, 64, and so on and so forth to get the rest of these products. That's where they came from. We're going to say this is equal to 57 minus -32, which is equal to 89. So our determinant of A is equal to 89. All right, now let's go ahead and give you all some practice here. Let me write out another matrix. We'll say this time B is equal to the matrix, another 3 by 3, 2, -6, 5, 4, -7, 1, 2, and 4. So go ahead and see if you can calculate the determinant of B on your own. You can pause the video for a little bit and then we'll go over the solution together. All right, let's take a look and see how you did. So again, let's copy down our first two columns here. Now, if I'm going through and finding my 3 diagonals to get my determinant, I'll have the determinant of B is equal to, and I'll write my products here. These are the products we should have been getting: 48, -14, -60. Then we're going to subtract our other 3 products, -24 plus 42 plus 40, which, once we're all said and done, we should be getting a determinant of 180. All right, so that's what the matrix determinant looks like, but let's see how we can use this to help us